Good job. Good, good. Good. Yes, yes, yes. Good, good. Mm-hmm. Ooh, you're really close. You're really, really close. I'm gonna wait another moment. We'll wait one more second. And then we'll go through them. Scarlett, you got something written down? Let me see what you got. Yes. You know what's going on. Not quite. Okay. Oops. Okay, so let's look at this one up here. Do I need to move a factor away from n, or a term away from n? Yeah, I need to move this term. I need to move the 2. How do I get rid of this 2? I got to subtract 2 because that's going to get me to 0 over here. But if I subtracted 2 over here, I got to subtract 2 over here as well. So now I have n all by itself. N equals -8 minus 2, which is what? -10. Good. What about in the next one? Am I moving a factor away from n or a term away from n? What's the term that I need to move? Yeah, that 5. How do I get rid of the 5? Yeah, I have to add 5 because that's the opposite of -5, right? That's going to get me to 0. So I add 5 to both sides. And so I've got n all by itself over there. N is equal to 10 plus 5. Good. What about this one? Do I need to get rid of a term or a factor of k? A factor this time, right? Because they're smushed together like that, 14 and k. And what does 14k, what does it mean? 14 times k. So how am I going to get rid of this 14? I have to divide. What am I dividing by? I have to divide by 14, right? Because 14 over 14 is going to just cancel out to be 1. But if I divide this side by 14, I have to divide this side by 14. What's -182 divided by 14? Good, -13. So that's going to be our value for k. And then what about here? Am I moving a term or a factor? A factor again, because that m and 11 are smushed together like that. How do I get rid of the 11? I've got to multiply, right? Because this is m divided by 11. So I do the opposite. If I multiply this by 11, those cancel out. But if I multiply this side by 11, I got to multiply that side by 11. So now I have m equals, good, -154. Very good. What did you do? That's what we did. Right? Okay, let's move over to the back. Leland, let's take out our paper from yesterday. I'm going to just erase this because we don't need that anymore. And we're going to go through some of these problems. I'm going to do the odds with you, and I'll have you do the evens. We'll do them together on the whiteboards. So we're still going to use the whiteboard. So let's look at number 1. So we don't just have one operation here. We have 2 operations now. We talked about this yesterday. So our first step has to be moving the term. So our first step is always move the term. And then my second step is going to be moving the factor. So in number 1, what is the term that I'm going to need to move? Yeah, that's 7. And what is the factor that I need to move? 4. Good. So first step is removing that term. So how do I get rid of that 7? Yeah, I've got to subtract 7 from both sides. And that's going to make this 0 out. So now I've got 4b equals -24. And then what do we do? Yeah, I got to divide both sides by 4. because that's going to cancel those out. 4 over a 4 is just 1. So now I have b all by itself. B equals negative 24 divided by 4, negative 6. Good. So I want you guys to try number 2, please. Try number 2. Do it on your paper, and then show me your answer on the whiteboard. Good, Kaya. You're close, Haven. Yes. Try again. Try again. Good job. This one's a little bit funky. I'll explain why in just a second. Huh? Not quite, Josie. You're close, but no. You're close, Sarah. You're close, Matthew. Close, Scarlett. Good job. So try number 2. It's just like number 1. Just like number 1. Move the term first and then move the factor. So let's talk about that. So what is the term? You're close, but no. What is that's it. What's the term that I need to get rid of? 7. How do I get rid of this plus 7? Not quite. Minus 7, minus 7. That's a negative 10 minus 7. Close. Negative 10 minus 7 is what? Negative 17. So now I have negative r equals negative 17. What's the factor that I need to move? Close, but no. But what's like the number there? Because there's an invisible number there. It's a negative 1. So when I see something like that, I see negative x or negative r, that means negative 1 times x or negative 1 times r. So now how am I going to get rid of this factor of negative 1? You could technically multiply, but yeah, I need to not add. If I added 1 to both sides, that's not going to get me there. I got to divide by negative 1, or I could multiply really, but if I divide both sides by negative 1, right, those cancel out. So now I have this positive r equals a positive 17. So you'll see that as a pattern. If you ever end up with something like this, negative x equals negative 6, that just means that positive x is going to equal positive 6. Or if I have negative y equals 9, then that means that positive y is going to equal negative 9. You see that? That makes sense? Okay. So now let's look at number 3. So I haven't shown you number 3 yet, but let's talk through this. So I have got a couple of operations going on in number 3. What operations do we have? What's that? Yeah, what does that 10 out in front of the parentheses mean? Multiplication. And what else do we have? Yeah. So normally we would say, right, if I was following PEMDAS, I'd do the multiplication first and then the addition, but what's wrong about that? There's parentheses, so I have to actually do, right, my parentheses first and then the multiplication, right? So now when I undo it, I have to go backwards. So I have to undo the multiplication using what? Division, and then I undo the stuff in parentheses. We'll deal with that. So what am I multiplying by in number 3? 10. So how do I undo multiplying by 10? Divide by 10. Divide by 10. Right? What happens to these 10s? They cancel out. So now I have 10 plus p equals, what's negative 100 divided by 10? Negative 10. And now what am I going to do to get the p by itself? Good. I'm going to subtract 10, right, from both sides. So now those cancel out to be 0, and p is going to equal negative 20. Did anyone else try and solve that another way? Kaya, can you tell me what you showed me you were doing? Distribute. Yeah, so you can do it this way too, where we distribute first. So 10 times 10, that's 100. And then 10 times p, that's 10p equals negative 100. And then I could solve it from there, right? I move my term first. I move that 100 over 10p equals negative 200. And then I move my factor of 10, and I'm going to get the same exact answer, negative 20. So in certain problems, we do have to do it this way, but for right now, this is good. We can kind of take a little shortcut and do it this way instead. I'm losing my voice. Okay, I'm going to erase that because we don't really need that right now. And I want you to try number 4. Try number 4. It's just like number 3. Try number 4. It's just like number 3. I think so, but let me remind myself because I don't want to tell you the wrong thing. Yes, yes. Yes. Nope. Try again. Try and follow. Yes. Try again. Try again. Good. I'll give you a couple more minutes, a moment or two. So always subtract from the side that has the variable. Yeah. You're close, David. That's it. Good, good, good. Not quite. Yep, just take the passing sign out, please. Not quite. Try again. So let's talk through it. Let's talk through it. So what's my first step? Well, first of all, what are the 2 operations I have in here? Yeah, but what's the addition inside of? Yeah, right? So I need to undo my multiplication first using division, and then I'll deal with my parentheses. So what am I multiplying by over here? The negative 6. So how do I undo multiplying by negative 6? Divide by negative 6. Right? What's negative 102 divided by negative 6? 17. So 17 equals r plus 3. And then what do we do? Yeah. What? Divide? Why is it subtract? Yeah. Because we are adding 3, so I undo that by subtracting. Subtract by 3 over there, so I get 14 equals r. Good. We can skip 5 and 6 for now, and I want to look at 7 and 8. 7 and 8. So 7 and 8 is kind of similar to 3 and 4, and I want to show you why. So if just pause on 7 and 8 for a second, let me show you this. If I gave you something like this, what would you do? But I thought division came before addition. Hold on, just evaluating this, huh? Yeah, the top, it's almost like the top has parentheses around it, right? So we do that part first, and then we divide. So I add first, and then I divide, right? So then I get 3, yeah? So that's kind of what I want you to think about for 7 and 8. When we see problems like this, it's almost like there's parentheses up here, right? Parentheses up here, okay? So now I've got parentheses, and what other operation do I have? Yeah, but that's subtractions inside the parentheses, so we'll worry about that later. What else do we have? Division, right? So I would do my parentheses first, and then I divide. That's what I did up here. But when we're undoing, we go backwards. So I undo my division by multiplying, and then I undo the stuff in parentheses, okay? So what am I dividing by in number 7? 11. How do I undo dividing by 11? By what? So I got to multiply both sides by 11. These 11s are going to cancel out. So now I've got n minus 8 equals negative 2 times 11, negative 22. Okay, now I just have this subtraction here. How do I undo the subtraction? Yeah, I'm going to add 8. So now I have n equals negative 22 plus 8. Good, negative 14. Okay, you guys try number 8, please. Try number 8. Good. Good. Close. Do you see why? Good job. Can I see? So what am I going to do first? Yeah. So I've got those parentheses there with the addition inside, and then I have division, right? So I need to undo the division first by multiplying, and then I'll deal with my parentheses. So I'm going to multiply by 4 on both sides. These 4's cancel out. A lot of times people will want to like take the 4 and multiply the v and the 9. We don't need to do that. I have a numerator, I have a 4 in the numerator and a 4 in the denominator. Those just cancel out to be 1. And then I've got 4 times 2 over here. What's 4 times 2? 8. And that equals v plus 9. So now how do I remove that addition? Subtract 9. Subtract 9. So v equals negative 1. Let's do 9 and 10 together, and then I'll give you time to work. So let's look at number 9. So remember, we need to move the term first. And then we move our factor. So what is the term that I need to move first? Good, the negative 10. What's the inverse of negative 10? Positive 10. Even though I'm adding, right, I need to still add 10 there because that's what's going to get me to 0, right? If I subtract 10, that gives me a negative 20, and that doesn't help. So I need to add 10 to both sides. So I've got 2 equals R. What does that line mean? Divide. Good. So now how am I going to get rid of this divide by 4? Multiply by 4 on both sides. So what does R equal? Good. Can you guys do 11 or number 10, please? Number 10. Good, good. Can you write it a little differently? No, not quite, David. Yeah, that's good, Micah. You might be right, Haven. I just couldn't read it. Try again. Looked like that, but not quite that. Try again. Yes. Yes. Good. Yes. Good. Good. So first I move my term. What is the term that I need to move? Yeah, the 1. How do I get rid of that 1? Yeah, I have to subtract 1 from both sides. That's 9 minus 1. 8. So I've got 8 equals x over 2. Those canceled. And now I've got this factor of 2, right? I'm dividing by 2. How do I undo dividing by 2? Multiply by 2. So I have those 2's cancel out, and x equals 2 times 8. Okay. So you guys need to finish up. You can skip 11 and 12, but 13 through 24. 13 through 24. Okay, and I'll see how far you get in the next 5 minutes and come walk around. But we're doing that by the end of class, 13 through 24. You've got example problems here on this side. Every single one, 13 through 24, there's a similar one on the other half of the paper. Yes, I know. Can you still take it with you? That's the hall pass. Thank you. Let's put some scotch tape around it before you go. Oh, you see the tape over there by my hole punch by the window? And just do a big piece of that. Just wrap it around it. Thank you. Mm-hmm. 11. Let's see. So plus 4. That's 1. Mm-hmm. And I'm not looking, you don't need to show your birth necessarily. You could do it on the whiteboard if you wanted to, for 13 through 20. But 21 through 24, I'm going to need to see your work. Yeah. Huh? Okay. What one are you looking at? 14. 14? So what did you do first? And now, what's this? Okay, good. And then this side, since that cancels out, this is all I have left. Does that make sense? And then I can kind of keep it in there.
Let's get 15. Negative 13, not 15. Yeah. I just said that.
If you have not, if you're still on the multiplication or the multiple choice problems, I want you to move down to 21 through 24. If you're still working on the multiple choice, just skip down to 21 through 24. Yeah, I'll be back.
You can see what problem. I figured it out.
Yeah, but you don't tell me you're not even on your work. I told you you need to show me your work.
But it's like too small.
I can't give you full credit unless you send me the work. You've been doing really good, Lily, so I believe you that you're doing it, but I said that you need to do your work on it. Let me see again next week.
Yeah.
And then what do you do? And then you'll get the rating star. Hi. Yeah, so now what do you do to get to stay by yourself? Mm-hmm. So what's the music 34? Yeah. Very good. Right? Fine. Yeah. Yeah. So, for what class is it? Yeah, so he would just make a mistake. And I would email him and tell him, can you change it? Because I was here yesterday. Does that make sense? Yeah. Because we still have access to it for a few days. But yeah, tell him. Because it's really not that big of a deal. But maybe your aunt got an email or a phone call or something, and you were missing. Okay. And also it'll show up as like you missed 10 days, but really you only missed 9. So it's not going to be a big deal for you because you don't miss a lot. But I would still tell him tomorrow, like, you marked me unverified on Monday, but I was here. Can you change it? And yeah, you could email him or okay. Cool. Yeah, thanks, Tina. Isn't that a good thing? Yeah, it's better to get it cleared up, I think. Yeah. Okay. Cool. Okay. Bye, Tina. Have a good night.